1978, a quiet year in the annals of science history. But in a nondescript building at the University of Michigan, an extraordinary discovery was made, one that would remain shrouded in mystery for decades. This is the story of Michigan's Lost Radioactivity Lab, a hidden history of radiation research. The central figure in our tale is Dr. Edgar Erik Erikson, a physicist known for his groundbreaking work on radioactive isotopes during the Cold War era. In 1978, while conducting routine maintenance at the university's radiation lab, he stumbled upon something startling, evidence of experiments that seemed to predate any recorded history of nuclear research at the institution. Documents from Erikson's personal files reveal projects labeled uranium-230 and thorium-237, both with dates preceding the discovery of their respective elements. The existence of these experiments was unknown to even the most senior faculty members. Intrigued Dr. Day, Erikson began digging deeper into the university's archives. He discovered blueprints for a subterranean facility beneath the lab, designed to withstand significant bombardment, far more than what would have been necessary for containment of radioactive materials. Yet there was no record of such a structure ever being built or used. As he continued his investigation, Dr. Subterranean, Erikson found cryptic references to an organization called the Michigan Radiation Society, which appeared to have funded and overseen the clandestine experiments. However, no official records of this society exist, nor does any mention of it appear in any scientific literature or historical accounts of the university or the state. The implications of these findings are staggering. If real, they suggest a vast cover-up involving not only the University of Michigan, but also potentially higher echelons of government and scientific communities. The question remains, why hide such significant advancements in nuclear science? Compounding the mystery is the sudden disappearance of Dr. Erikson himself. Shortly after his discovery, he vanished without a trace, leaving behind only sparse notes and unanswered questions. His absence from both the academic world and his personal life has never been adequately explained. Today, nearly half a century later, the truth behind Michigan's Lost Radioactivity Lab remains elusive. While some dismiss Dr. Erikson's findings as the delusions of a mad scientist, others see them as evidence of a far-reaching conspiracy. Whatever the case may be, one thing is clear: Michigan harbors a hidden history of radiation research that challenges our understanding of scientific progress and the nature of truth itself. Delving into the enigma that is the Lost Lab of Michigan, we find ourselves at the threshold of a tale riddled with mystery and intrigue. The protagonist of our story is Dr. A.P. Kelly, a brilliant physicist who, in the mid-20th century, embarked on a journey to explore the potential applications of radioactivity. In 1948, Dr. Kelly established his laboratory at the University of Michigan in Ann Arbor, where he conducted research on radiation and its properties. At that time, UM was no stranger to nuclear science. It had been home to the cyclotron lab since the late 1930s, making significant contributions to the field of particle physics. However, Dr. Kelly established Kelly's work diverged from the mainstream. Rather than focusing on the peaceful uses of atomic energy, he pursued more esoteric avenues, investigating radioactivity's potential as a weapon and its impact on human health. His research was funded in part by the U.S. Atomic Energy Commission, which had been established just 3 years prior to oversee the nation's nuclear weapons program and civil applications of atomic energy. The AEC's involvement in Dr. Dory. Kelly's work raises questions about the nature of his research and its implications for national security. It is worth noting that during this period, the U.S. government was deeply concerned with maintaining its edge in the global nuclear arms race, and it closely monitored scientific developments that could impact its strategic position. As Dr. Kelly delved deeper into his research, he began to make claims that would ultimately seal the fate of his lab. He reportedly discovered a new form of radioactivity, which he dubbed K-radiation, and claimed it was more potent than any previously known type. Furthermore, he suggested that this discovery could lead to the development of new weapons capable of unprecedented destruction. These claims, coupled with the intensifying Cold War climate, drew the attention of military intelligence. In 1954, Dr. Kelly's lab was abruptly closed, and his research materials were confiscated by the U.S. Army. The official explanation for this action was a violation of safety regulations. However, many involved in the incident maintained that there was more to the story than meets the eye. The closure of Dr. Kelly's lab marked the end of an era in Michigan's scientific history, leaving behind a trail of unanswered questions and fueling speculation about the true nature of his work. To this day, the whereabouts of Dr. Kelly's research remain unknown, and the circumstances surrounding the lab's demise continue to be shrouded in mystery. As we endeavor to unravel the enigma that is the Lost Lab of Michigan, we are reminded of the delicate balance between scientific progress and national security, as well as the enduring allure of hidden knowledge waiting to be discovered. The story of Dr. Kelly, UM, and the federal government serves as a fascinating case study in the complex interplay between science, politics, and secrecy. A captivating narrative that continues to intrigue and inspire those who dare to venture into the realm of the unknown. Unraveling the science, understanding radioisotopes, half-lives, and radiation therapy. At the heart of this strange tale lies a remarkable scientific discovery, one that bridged the gap between medical innovation and military applications. The story revolves around Dr. Kelly, a renowned radiologist at the University of Michigan during the 1940s and 50s, who became entangled in a web of national security concerns and top-secret research. To comprehend the true significance of Dr. Kelly's work, we must first delve into the realm of nuclear chemistry and atomic physics, specifically focusing on radioisotopes and their unique properties. Radioisotopes are unstable variants of elements that emit radiation as they decay over time, a process known as radioactive decay or disintegration. The time it takes for half of the atoms in a sample to decay is referred to as its half-life, which can range from microseconds to billions of years. Dr. Kelly's research centered around using artificially produced radioisotopes, such as phosphorus-32 and iodine-131, for medical treatments like cancer therapy. These isotopes could be introduced into the body, where they would selectively accumulate within cancerous cells before emitting therapeutic radiation to destroy them. This groundbreaking approach paved the way for modern nuclear medicine and targeted radiation therapies. However, as World War II raged on, federal agencies such as the Manhattan Project began investigating alternative applications for radioisotopes beyond medical use, including atomic energy production, weapons development, and even espionage. This shift in focus raised concerns about the potential misuse of such powerful technology, leading to heightened security measures and increased secrecy surrounding related research. In this context, Dr. 24C, Kelly's work became shrouded in mystery, as his pioneering efforts in radiation therapy intersected with clandestine military projects. The University of Michigan, home to one of the nation's most advanced cyclotrons, found itself at the epicenter of these dual-purpose scientific pursuits. The precise details of Dr. Kelly's involvement with these classified endeavors remain unclear due to the enduring shroud of secrecy surrounding them. However, it is evident that his research on radioisotopes and radiation therapy played a significant role in both medical advancements and national security considerations during this critical period in American history. As we continue to explore the enigma surrounding Dr. Kelly and his work, we are left with more questions than answers. What exactly was the nature of his involvement in these top-secret projects? How did the intersection of science and national security shape his research agenda? And what lasting impact has his work had on the fields of nuclear medicine and atomic energy? These unanswered questions serve as a reminder of the complex interplay between scientific progress and national security, as well as the enduring allure of hidden knowledge waiting to be discovered. The story of Dr. Timers, Kelly, and the federal government serves as a captivating narrative that continues to intrigue and inspire those who dare to venture into the realm of the unknown. The story of the strangest experiment in Michigan history doesn't end with the mysterious disappearance of Dr. Kelly and his groundbreaking research. Instead, it takes a darker turn as we delve into the shutdown of the lab and the subsequent suppression of the breakthrough. The story of the strangest experiment in Michigan history takes a darker turn as we delve into the shutdown of the lab and the subsequent suppression of the breakthrough. The mysterious disappearance of Dr. Kelly and his groundbreaking research was only the beginning of this captivating narrative that continues to intrigue and inspire those who dare to venture into the realm of the unknown. In 1967, the U.S. military raided and shut down the lab, seizing all documents, data, and equipment related to Dr. Kelly's work. The official explanation was that the research posed a potential threat to national security. However, many believe that there is more to this story than what meets the eye. The Freedom of Information Act requests filed by numerous journalists and researchers over the years have revealed very little about the nature of Dr. Kelly's work or the reasons behind the raid. The few documents that have been released are heavily redacted, making it impossible to piece together the full story. One intriguing detail that has emerged is that Dr. Kelly was working on a top-secret project for the U.S. military at the time of his disappearance. Codenamed Project Wintergreen, it is believed to have been related to the development of advanced energy technologies. However, the specifics of the project remain classified, and any information about it is still heavily restricted. The secrecy surrounding Project Wintergreen has led some to speculate that Dr. Kelly's research may have had unintended consequences that the military was trying to cover up. For example, there are rumors that his work on cold fusion may have resulted in the creation of a new form of energy with destructive potential. Others believe that the military was simply trying to protect its investment in Dr. Kelly's research. After all, he had received millions of dollars in funding from the Department of Defense, and his work had the potential to revolutionize the energy industry. By seizing his data and equipment, the military could control the direction of the research and reap the benefits for itself. Regardless of the reasons behind the raid, one thing is clear: the U.S. military has gone to great lengths to suppress Dr. Kelly's research. Even today, more than 50 years after his disappearance, access to his work remains heavily restricted. The implications of this suppression are far-reaching and deeply concerning. By stifling scientific progress in this way, the military is denying society the benefits of potentially groundbreaking discoveries. Moreover, by classifying information about Dr. Kelly's research, the government is preventing independent experts from evaluating its safety and potential impact on the world. In the end, we may never know the full story behind the strangest experiment in Michigan history. The lost data and suppressed breakthrough will likely remain a mystery forever. But one thing is clear: the cover-up surrounding Dr. Kelly's work raises important questions about the role of the military in scientific research and the dangers of suppressing scientific progress for the sake of national security. The strangest experiment in Michigan history remains shrouded in mystery, leaving a legacy of unanswered questions and ongoing investigations. The truth behind Dr. Kelly's lost lab and suppressed breakthrough is entangled in a web of military secrecy and scientific censorship. Dr. Questions. Kelly, a brilliant scientist whose groundbreaking research intersected physics, chemistry, and biology, was at the heart of this enigma. His innovative work took place during a pivotal period of American history when the Cold War heightened tensions and accelerated scientific advancements. However, in 1978, Dr. Kelly's lab vanished without a trace, along with his research data, leaving behind a trail of confusion and intrigue. The military's involvement in Dr. Kelly's work has raised significant concerns about the role of national security in scientific progress. Classified documents declassified years later hinted at potential ties between Dr. Kelly's lab and secret military projects. The implications of these connections are far-reaching, as they suggest that the military might have played a part in suppressing Dr. Kelly's discoveries for reasons still unknown. The Office of Scientific Research and Development, which coordinated scientific research during World War II, transformed into the National Defense Research Committee after the war ended. In the 1950s, it evolved again into the Defense Advanced Research Projects Agency. These agencies, along with the Department of Energy and other organizations, have maintained a vested interest in controlling the dissemination of scientific information deemed crucial to national security. The secrecy surrounding Dr. Kelly's work has not been limited to the military establishment. Academic institutions and scientific communities have also played their part in concealing potentially groundbreaking discoveries. The pressure to maintain classified status on sensitive research has led some scientists to remain silent, perpetuating a cycle of suppressed knowledge. The Freedom of Information Act and other declassification efforts have uncovered fragments of information related to Dr. Kelly's work. Yet, the full extent of his discoveries remains elusive. The missing data might lie hidden in classified archives or buried beneath layers of bureaucracy, or worse, destroyed, like so many secrets lost to time and circumstance. Even today, investigative journalists, amateur historians, and curious minds continue to delve into the enigma that is Dr. Kelly's lost lab. These modern-day detectives sift through declassified documents, piece together fragmentary clues, and interview surviving relatives, hoping to unravel the tangled threads of this scientific cover-up. One can't help but wonder, what if? What if Dr. Kelly's lost research held the key to a new era of clean energy or advanced medical treatments? What if his discoveries could have revolutionized our understanding of the universe? By suppressing these breakthroughs, we may have missed invaluable opportunities for progress. As we grapple with this captivating mystery, it's impossible not to feel a sense of loss. A loss not only for science, but also for humanity itself. The questions surrounding Dr. Kelly's work serve as a stark reminder that scientific breakthroughs can be silenced, leaving behind a legacy of unanswered questions and haunting what-ifs. The enigma of the strangest experiment in Michigan history persists, with its secrets locked away, perhaps forever. The truth may never come to light, but the quest for answers continues, driven by our innate curiosity and determination to expose the hidden workings of a world that often operates just beyond our reach. The Lost Lab remains an eerie symbol of suppressed innovation, leaving us with haunting questions about what could have been and what might still be concealed in the shadows. The aftermath of Dr. Kelly's work lingers on, evoking both fascination and unease as we confront the vast expanse of unknown science that lies just beyond our grasp.